Hello, science fans. We live on a big, beautiful, round planet. It's a sphere, much like a giant ball. We know this from many cool observations and scientific discoveries. Astronauts in space have taken amazing photographs of our round Earth showing its lovely curve. When ships sail away from the shore, they appear to sink hull first over the horizon. These are clear clues that tell us our Earth is not flat. But what if it was? Today, we are going to perform a thought experiment. We will explore what our world might be like if it were hypothetically a flat disk. Let's imagine this very different Earth together, because science is all about asking what if and exploring fascinating ideas. The idea of a flat Earth is a very old one. Many ancient cultures tried to understand the world around them using the tools and knowledge they had. They observed a flat-looking horizon and naturally thought Earth might be a vast, flat surface. It is quite an understandable idea from a long, long time ago, before we had modern science. Now, of course, we have gathered much more information and developed incredible technology. We know with certainty that Earth is a globe. However, thinking about a flat Earth can be a really fun way to learn. It helps us better understand why our round Earth works in all its amazing ways. So, let's put on our scientific thinking caps for this imaginative adventure. If the Earth were indeed flat, so many fundamental things would change quite dramatically. We are talking about things we experience and see every single day, things we often take for granted. Consider gravity, the invisible force that keeps our feet firmly on the ground. Think about how we experience the cycle of day and night, allowing for periods of light and darkness. Or consider why we have different seasons, such as the warmth of summer and the chill of winter. All these familiar phenomena depend entirely on Earth being a sphere. A flat Earth would mean a completely different set of physical rules would apply. It's like changing the basic design of our home planet in a very big way. Our important mission today is to investigate these potential changes in detail. We will look closely at how gravity might behave, what seasons would be like, and how day and night would occur, or, more accurately, how they probably wouldn't work as we know them at all. This exploration is not about trying to convince anyone that Earth is flat, because it isn't. It's about using the power of scientific thinking to understand our actual, wonderfully spherical world much better. By imagining an impossible scenario like a flat Earth, we can truly appreciate the amazing and elegant science of our real planet. So, are you ready to explore a pancake-shaped planet with us? Let's begin. Let's talk about gravity. On our round Earth, gravity is a fundamental force that pulls everything towards the very center of the planet. You can imagine Earth as a giant apple if you like. The core of that apple would represent Earth's center. Gravity pulls you, me, and everything else towards that central core. That's precisely why, no matter where you happen to be standing on Earth, the direction of down is always towards your feet, towards the ground. If you drop a ball, it falls straight down. This consistent downward pull is because the enormous mass of the Earth creates this powerful gravitational field. It's a very steady and predictable force on our spherical home. Now let's switch our thinking to a flat disc-shaped Earth. How would gravity work in such a place? Well, if the Earth was a flat disk, physicists believe gravity would pull everything towards the geometric center of that disk. This means it wouldn't pull straight down for everyone unless you were standing right in the very middle of the disk. If you stood near the edge of this flat Earth, gravity would tug you sideways, strongly towards the center of the disk. It would feel as though you were constantly standing on an incredibly steep hill, and you'd be fighting not to slide inwards. Walking towards the edge would be like climbing a very steep incline. This persistent sideways pull towards the center would cause some enormous problems for inhabitants. All the water on this flat Earth, the oceans, lakes and rivers, would inevitably flow towards the center. It would gather to form a gigantic ocean right in the middle of the disc-shaped world. Consequently, the edges of this flat Earth would likely be extremely dry, barren and largely uninhabitable. It would be incredibly difficult, if not impossible, to live anywhere except perhaps near the very center. Imagine trying to build a house or a city on a permanent, very noticeable slope. Trees would probably grow leaning inwards, and life would be a constant, tiring struggle. And what about the atmosphere, the precious air we breathe? It too would be affected by this central gravitational pull. The air would be densest and thickest at the center of the disk, where the pull is strongest downwards. As you moved further out towards the edges, the atmosphere would become progressively thinner. At the very fringes of the disk, the air might even be too thin to sustain life as we know it. Here's a fun fact. If this flat Earth disk was very, very thick and massive, gravity would actually try to pull all that mass into a sphere. That is because gravity always works to pull matter together as compactly as possible, and a sphere is the most compact shape there is. On our familiar round Earth, we experience the wonderful cycle of seasons: spring, summer, autumn, and winter. These seasons occur because our Earth is tilted on its axis by about 23.5 degrees. It's like a spinning top that is leaning over just a little bit. As our Earth orbits the Sun on its yearly journey, different parts of the planet receive more direct sunlight at different times. When the northern hemisphere is tilted towards the Sun, people there experience summer. Conversely, when it's tilted away from the Sun, it's winter in the northern hemisphere. This axial tilt is the clever mechanism that gives us our changing seasons and diverse climates across the globe. Now, let's try to imagine seasons on a flat Earth. This becomes very tricky indeed. Some flat Earth models propose that the Sun is a small, relatively close object that circles above the flat disk of the Earth. To explain seasons, these models might suggest that the Sun moves in a wider circle during winter, making it appear further away and providing less warmth, and a tighter, closer circle during summer. If the Sun moved further away or higher up, things would naturally get colder. If it moved closer or lower down, things would get warmer. However, this scenario would also mean that the Sun would appear to change its size in the sky quite significantly, which is not what we observe with our seasons. The climate on this hypothetical flat Earth would likely be quite extreme and not very pleasant. If the Sun, as a small heat source, hovered mainly over the center of the disk, that central area would probably be scorching hot all the time. The further you traveled from the center towards the edges of the disk, the colder it would become. The outermost edges of this flat world might be permanently frozen, encased in ice and snow. There would be no gentle, gradual transition of seasons like the spring or autumn we are accustomed to. Instead, you would likely have a very hot zone, perhaps a narrow temperate zone, and then a vast frigid zone. Furthermore, weather patterns would be completely different from what we know. Strong, persistent winds might blow constantly from the superheated central region towards the cold periphery of the disk. This would create a very unusual and probably quite harsh global wind system. Fun fact, on a flat Earth with a small local sun acting like a spotlight, everyone on the disk would theoretically see the Sun at the same time. It would just appear at different angles in their sky and look smaller and dimmer for those further away from it. Crucially, the Sun wouldn't set below a horizon in the way we experience it. It would just move away and shrink. The way day and night occur on our spherical Earth is a beautifully simple and elegant process. Our planet spins on its axis, much like a basketball spinning on a professional player's fingertip. This complete rotation takes approximately 24 hours, which defines the length of our day. As Earth spins, one side of the planet faces the Sun. This side experiences daytime with light and warmth. Simultaneously, the other side of the planet faces away from the Sun, into the darkness of space. This side experiences nighttime. This constant, steady spinning is what gives us the regular and predictable cycle of day and night that governs life. On a flat Earth, however, creating a convincing day and night cycle becomes a significant puzzle. If the Sun is imagined as a small spotlight moving in a circular path above the flat disk, as some flat Earth proponents suggest, then yes, the area directly underneath the Sun would be illuminated and experience day. Places further away from this spotlight would be in dimmer light, or what could be called night. But a major issue arises. Everyone on the entire disk would theoretically be able to see this Sun all the time. It would just appear smaller and fainter when it was positioned over a more distant part of the disk. It wouldn't actually disappear below any kind of horizon. There are many straightforward, everyday observations that clearly debunk the outdated idea of a flat Earth. For instance, when a ship sails away from you towards the horizon, its hull disappears from view before its mast does. This happens because the ship is gradually moving over the curve of the Earth. If the Earth were flat, the entire ship would simply get smaller and smaller until it was too tiny to see, but it would all shrink proportionally. Furthermore, during a lunar eclipse, the Earth passes between the Sun and the Moon. The shadow that our Earth casts on the Moon is always round. Only a spherical object consistently casts a round shadow from any angle. Another fascinating fun fact is that people living in the northern hemisphere see a different set of stars in the night sky compared to people living in the southern hemisphere. For example, the famous Polaris, also known as the North Star, is only visible to observers in the northern hemisphere. Similarly, the constellation known as the Southern Cross is only visible from the southern hemisphere. This phenomenon would be impossible if the Earth were flat, as everyone would be looking up at the same celestial dome. So while imagining a flat Earth is certainly an interesting thought experiment, the scientific evidence for our spherical Earth is absolutely overwhelming and visible all around us. Science truly rocks.